Okay, there's two postulates that we're going to go over today. We've heard the word postulate before. You know, the segment addition postulate, the angle addition postulate. Postulate is something that we're given without proof. So it's something that seems so basic that we don't need to prove it. It's one of the assumptions that we base everything on. These are the most complex postulates that we're going to have. If you think of the segment addition postulate, you know, if I take a segment and add it to a segment that's connected to it, that equals the whole segment that they make. That's one that's so basic that we do it without proof. This one is not that basic, and it's actually something that if you interpret it different ways, it can spawn completely different types of geometry. So I'm going to go over the way that we're going to use it. So the first one's the parallel postulate. And very similar to the parallel postulate is the perpendicular postulate. So what the parallel postulate says is, if you are given a point and a line, then there is one and only one line that goes through the point and is parallel to the line that you're given. Okay, you could say the same thing about perpendicular. If you're given a point and a line, there is one and only one line through the point that is perpendicular to the line. So I've got the situation they're talking about. If we're given a point and a line, so I've got a point and a line here. What it says is there is only one line I can draw that's going to go through this point and be parallel to the blue line. Or if you're following the perpendicular one, there's only one line that will go through this point and be perpendicular to the blue line. So yesterday we looked at writing equations for lines that are perpendicular or parallel. I'm going to build off of that to kind of show how it relates to these postulates. So if I want the line that's parallel to the blue line and goes through the point, well, first I need to know the slope. So the slope of the blue line, if I can pick a point where I definitely can see that it's crossing. Okay, that point right there, it's definitely crossing, you know, an exact point there. Here's another one that I can use. So I'm going to check what my slope is. I'm going up 2 and over 3. My slope looks like it's 2/3. I'm going to check just to make sure. I'm going to find another spot here. Make sure it's still up 2 over 3. Okay, so yeah, that's my slope. I've got this point here. This point is at -3, 5. So I can use that information to write the equation of the line. So I'll do y minus y1 equals mx minus x1. Since I want parallel, I'm going to use the exact same slope. So my slope is still going to be 2/3. My x-coordinate from the point I want it to go through is -3. So minus a -3 becomes +3. Y minus the 5 gives me this. If I distribute, I get 2/3 x plus 2. And then I add the 5 over, so I get y equals 2/3 x plus 7. So if I graph that, 2/3 x plus 7, I'll go up to 7, 1, 2, 3, 4, 5, 6, 7. I can go up 2 over 3, or I can go down 2, back 3, down 2, back 3. Okay, but I get this red line here. Okay, that's the only line I can draw that touches that point and is parallel to the blue line. Okay, and that should be clear because this is the only equation that I could possibly get if I'm given that point and that slope of the blue line. There's no other equation that I can make. Since there's no other equation I can get that meets those criteria, that kind of proves to us that the parallel postulate works, because we can see it algebraically. I do the same thing for perpendicular. So now if I want perpendicular, I'm going to have to change my slope. My perpendicular slope is going to be the opposite reciprocal. So change the sign, flip the fraction. I still want to go through the same point. I'm going to take y minus y1 equals my perpendicular slope times x minus x1, so it's going to become plus 3 again. Distribute now, I get negative 3 halves x minus 9 halves. Add the 5 over. I get negative 3 halves x. 5 is 10 halves, so I'm adding 10 halves to 9 halves. That leaves me, or to negative 9 halves, which leaves me with 1 half. That means if I graph this line, I would start at a half. And I'm going to go up 3, back 2. 1, 2, 3, back 2. 1, 2, 3, back 2. Okay, or I can go down 3. 1, 2, 3, right 2. Down 1, 2, 3, right 2. Okay, so I get this green line. Okay, which is perpendicular now. Okay, I made sure that they're perpendicular to these perpendicular slopes. Perpendicular to the blue line. Let me get rid of those red things. I've got that right angle there. Perpendicular postulate tells me this is the only line that's going to do that. The only line that's going to go through this point and be perpendicular to the blue line. And that's true because I'm only going to be able to make one equation using this perpendicular slope and this point. That's the only equation I'm going to make that's going to meet those criteria. Okay, because we talked about how we always want to be in this form. There's only one representation of an equation in slope-intercept form. So this kind of proves that. All right, so that's how we do it in the algebra world. Let's take it into the geometry world. All right, we're going to look at how we construct parallel lines and perpendicular lines given a point and a line. So we're still given the same things. So before we had algebra, there's still only one parallel line that could go through this point and be parallel to this line. But we didn't have coordinates and line graphs and things like that. So we just had our compass and our straight edge. So here's how you're going to go about creating these things. The first one's going to be something that's kind of similar to our bisecting a segment construction. So maybe I'll review that quick. In order to bisect a segment, okay, if I've got my segment here, okay, if you remember, I put it on the end point. I opened it up so that's more than halfway. I marked above and below the same distance. And then I came over to the other end point and I did the same thing. I marked below and above. Okay, and then I connected those with my ruler. Same time I'm going to use this. Now, that bisects the segment, but it also is perpendicular to the segment, and that's not something that we talked about. But this is a perpendicular bisector to the segment. So it actually is perpendicular to that segment. So we're going to need to do something similar in order to make a perpendicular segment that goes through the point. If I could make sure somehow that this is the point that I want to go through, then I could do that. So I want to go through the point that I'm given. If I could somehow bisect a segment and make sure that my two circles cross right on that point, then I'll guarantee that I'm going to touch that point and be perpendicular. So here's how we're going to make sure that we do that. I'm going to set this up as the intersection. Now, I don't have a segment, I have a line. But I can make a segment on that line that's equidistant from my point. If we look back here, by making these two circles, I made sure that this distance and this distance were the same, because they're both the radius of the same circle. This distance and this distance were the same. So the distance from the point to the end points of the segment were the same. All I need to do is make sure that this, okay, I'm going to open up my compass, and I'm going to make an arc like this. Okay, and where it crosses my line, that's basically setting up endpoints of a segment that are equidistant from the point that I'm trying to go through. So now all I have to do is bisect this segment. Okay, I already know it's going to go through my point, because I used my point to make sure I got these endpoints. I get this one, go down below. Okay, I'm going to come over to the other endpoint, cross there, right on the point, which is exactly what I want, and cross here on the other side. Now all I need to do is use my ruler. Put it down here. It's going to go right through there. It's not lined up very well. Okay, so line that up, and then I'm going to connect it. Now I've got a segment that goes through the point and is perpendicular to the line that I was given. Okay, and this is the only line that is going to go through this point and be perpendicular to this line. All right, let's look at making a parallel now. I'll move down here. So I need to be given another point. Okay, there's my point. I need another line to be parallel to. Let's do this one. Let's make it an actual line here. Okay, so now it's a line. Now, this is going to make more sense later in the chapter. We're going to revisit this later in the chapter to talk about why it actually makes a parallel line. But for right now, I'm just going to go through the motions of how you do it. So what you want to do is you want to make an angle. You want to make an angle using your line and your point. So I'm going to connect my line to my point to make an angle. Then what you're going to do is copy the angle you made. I'm going to copy this angle up here. If I can make the same angle up here that's down there, that's going to make a parallel line. So this would be a good review too. In order to copy an angle, I need to make a circle on the angle that I'm copying. Make the same circle up where I want to copy it. Okay, so now I've got points that are equidistant from the vertex. Okay, this is the same distance as this is. This is that same distance again. I just need to find how far I need to be away. Okay, so I've got the top part of my angle recreated up here. I've got the top part, just like I've got the top part here. All I need to do is find out how far the top part is from the bottom part. I need to open my compass up to that distance from the top. That's pretty close. Can't get it exact, but you can with your compass. Okay, so I'll open it up to that distance. If I copy that distance there, that's going to tell me exactly where my bottom line needs to run. It needs to run through that intersection. Okay, so I'm going to copy that up here. Okay, then I'll just connect those with my ruler, which doesn't want to turn for me. There we go. I'm going to go from here. I'm going to cross right there. It's pretty close. There's my parallel line. They look pretty close. Okay, but that's a parallel line. So it's just copying angle, which is something we've done before. Okay, so that's all you're going to work on. I've got a worksheet for you, which you'll work on next. If you need to rewatch this, just go ahead and back it up a little bit.